Dear friends, today I'm with you with another paper, fresh paper from 2024 May June, and it is paper 6, variant 3. Time allowed is 1 hour. This paper is of 40 marks, and 20% of the curve are the weightage of the quiz. So without any delay, we are starting this paper. For student, determines the density of modeling clay by two methods. Method 1 is using he uses the block of modeling clay as shown in figure, and we are supposed to measure. See, modeling clay block is in front of us in two different orientations. Measure the dimensions of the block, mean length, width, thickness of the modeling clay shown in figure 1.1. Record the values in centimeters to the nearest millimeters. In centimeters to the nearest millimeters. So we have to measure the length, we have to measure the width, and we have to measure the thickness or height. So when I'm measuring these values, of course, the values are not exactly according to the mark scheme answers. The reason for that, our values are sometimes greater, sometimes smaller, sometimes while using the screen, we are zooming it in, sometimes zooming it out. So not exactly the same values. So when I try to measure this length uh, from this point to this point, for me, it came to be 6.3 centimeter is written. When I'm going to measure this width, that is for me 3.1 centimeter. And height, it is 2.3 centimeters. Okay, now next is calculate the volume VA of the block. Use the measurements from AI and the equation. Always the equation or the formula is given. Even it's the easiest one, but still it is always given. So VA is equal to 6.3 times 3.1 times 2.3. So quickly let's see it. 6.3 times 3.1 times 2.3. So answer is 44.9. So 44.9. So here I'm writing 44.9 centimeter cube. Next. Suggest why the value of VA is only an approximation of the volume of the block. Describe how the accuracy of VA can be improved. Suggestion. Why this is only the approximation. You can check, especially the length, width, and height. All these values are not regular. Curved sides are there, even curved corners are there. So in very simple words, what can we do? We can write here that suggestion is uh, it is difficult to measure the irregular shaped, irregular shaped sides. So what to do? For each measurement, repeat at several place and take the average. So for each measurement, repeat at several places and find the average. That will be comparatively accurate. Next, record the mass MA of the block shown on the top pen balance in figure 1.2. So mass of this block, it is 80.4 gram. So they did not mention here to the nearest gram or nearest 0.1 gram. So we will be writing it exactly as it is. So this is 80.4 grams. One thing more, I just want to share. Sometime the examiner is asking, how can we make these measurements more accurate even without repeating? So the answer is, as it is a clay, modeling clay, so it can be reshaped. So we should place this modeling clay block into a regular shaped cube or rectangular block. Then compressing it, it will be shaped to the regular form. And we can measure the dimensions, means length, width, and height with accuracy, with greater rate of accuracy, greater percentage of accuracy. Okay, calculate rho A, the density of the modeling clay. You use your results from A, I, and C. So mass is 80.4 and volume was 44.9. 80.4 divided by 44.9. Answer is 179. I can round it off to 1.80 grams per centimeter cube. Mass is in grams and volume is in centimeter cube. You may be thinking, see, this was the value of the volume that I have used over there. Okay, let's move forward now. Method 2. The student then uses a smaller block of modeling clay and it is in front of you and a force meter is there. And a force meter is there. Now, record the weight of the modeling clay. See, 0.3, 0.4, it is in the exact center. So it means 0.35 Newton. The student poured water into a measuring cylinder. Record the volume V1 of the water in the measuring cylinder in figure 1.4. It means it is on the next page. We are always measuring from the lower level of punishment. 50, 52, 54, 56, 58, 60. So this is 56. So I'm going to write here 56. Next is, describe briefly how a measuring cylinder is read to obtain a value of the volume of the water. So how to read it? That is very simple. Line of sight should be at 90 degrees. Line of sight must be at 90 degrees. Only one 90-degree scale of the measuring cylinder. Now, the student lowers the modeling clay into the water as shown in figure. Now we need to read down the volume, new value of the volume. 70, 72, 74, lower level of meniscus. This is curved surface. This curved surface is known as meniscus. So here, my dear friend, 74, and it is already mentioned. Now we will move to the second value of density. Now, rho B is equal to WB, which is 0.35 times K, that is mentioned 100 gram, over V2 minus V1. It means it's 74 minus 56. So 0.35 times 100 equal to this 35 divided by, so 35 and then 74 minus 56, it is 18. So 35 divided by 18, answer is 1.94. 94. We can write it 1.90, and don't forget to write the unit grams per centimeter cube. Suggest which of row A and row B is likely to be more accurate value. So my dear friend, anyone you can choose. This is suggest. Justify your answer by reference to method 1 and method 2. Method 1 and method 2. So I will say method 2, as volume is measured directly. So row B in method 2 is more accurate as volume is measured accurately. Volume is measured directly. Better to say directly. No dimensions are measured directly. In this way, question number 1 is done. Question number 2. Student measures. A student investigates how the volume of water affects the rate at which the beaker cools. She uses the apparatus shown in figure. So there is a beaker, thermometer held vertically with the help of a stand on a bench, and a zoomed in image of the thermometer is shared. So record the room temperature, theta R, and what is its value? See, it is 15, 16, 17, and 18. So simply we can write here 18 degrees Celsius. The student pours a volume of 200 centimeter cube of hot water into the beaker and records the temperature theta of the water at T is equal to 0. So he records the temperature of the water in the beaker every 30 seconds. He pours the water out and pours 75 centimeter cube of hot water into the beaker again. The student repeats these temperature measurements for this volume of water. Now, state 2 precautions that can be taken to ensure temperature reading in the experiment are as accurate as possible. So first of all, we can write thermometer is not touching the sides, even you can say walls of the beaker. It dipped into the water such that bulb is into the water, bulb of the thermometer. Secondly, we can say line of sight. You have to measure it. Very common statement. The line of sight is at 90 degrees to the air of the thermometer, to the scale of the thermometer. Her readings are shown in table 2.1. Add units to the column headings in table 2.1. So time is in seconds, temperature is in degrees Celsius, and again temperature is in degrees Celsius. Write a conclusion stating how the volume of water affects the rate of cooling. Justify your answer by reference to the results. First of all, let's calculate the fall in temperature. 87.5 minus 79. So that is equal to 8.5 degrees Celsius. Fall of temperature is there. And when the volume is small, so delta theta 85.5 minus 67, 85.5 minus 67 equal to 18.5 degrees Celsius. So what can we observe? That rate of cooling is inversely proportional to the volume of water. Okay? Mean when the volume, okay, first of all, by reference to the result. So the curve with 200 centimeter cube of water. Fall in temperature is equal to 87.5 minus 79, 8.5 degrees Celsius. Then beaker with 75 centimeter cube of water. Delta theta is equal to 85.5 minus 67, that is 18.5 degrees Celsius. So what can we observe? When the volume of water is less, rate of cooling is more. So we can say the rate of cooling increases with decrease in volume of water. Like this you can write. And it is clear from the data. See here, temperature fallen is 18.5 degrees Celsius and the volume of water is 75 centimeter cube. When the volume of the water is more, the rate of cooling is less. Okay, I'm sure this will be very clear to you people. Now, this is very common nowadays. So using the values for 75 centimeter cube of water, calculate the average cooling rate x1 for the first 90 seconds of the experiment. Use the readings from the table 2.1 and equation. So theta 0, let's see, that is 85.5. This value and this value, sorry. So initial value 85.5 and then 75. So here I'm writing theta 0, 85.5 in temperature of the hot water initially at 0 second, 85.5, and at 90, that is 75 over T, which is 90 seconds. One is in degrees Celsius and this one in seconds. So 85.5 minus 75, it is equal to 10.5 over 90. So divided by 90, we are getting 0.116. So I'm writing here 0.12 degrees Celsius per second. So for the same beaker, we have to use now theta 90 and theta 180. Time is again 90 seconds. Theta 90 is 75 minus, we have used it already. And theta 180, see this is 67. 67. 67 over 97. 75 minus 67, 8 divided by 90, 0.08888. 0.888. So let it be 0.089 degrees Celsius per second. Okay. A student states that it is important to start the two experiments in B with water at the same initial temperature. Explain whether your values for x1 and x2 support this statement. Yes. X1 is not equal to x2 because starting temperature of hot water is not the same. Is not the same. Another student repeats the experiment. State two variables other than initial temperature, water temperature, that should control to obtain readings that are as close as possible in these to those in table 2.1. Very simple. Volume of the water, room temperature, even size of the surface area of the beaker, size of the beaker. So I'm writing the formula one. Very common. Volume of water must be kept constant. Secondly, room temperature. It must be kept constant for the repetition of this experiment. Okay, my dear friends. Now question number 3. A student determines the focal length of the converging lens. So illuminated object is there. U is given. The student sets up the apparatus as shown in figure 3.1. He sets the distance u between the illuminated object and the lens to be 25 centimeter. So he set it to be 25 centimeter in the beginning. Sorry, not u, 25 centimeters. He places the screen near the lens and moves the screen until a focused image of the illuminated object is seen on the screen. Describe a technique for obtaining an image that is as sharp as possible. So move the screen back and forth slowly. That means you move the screen backward or forward slowly. You have seen when a cameraman is there and you are there to get some good picture for your some interview, for your passport or some other official document. So he's not just clicking the flash. First, he will adjust your position and then very slowly, like let me share with you that with his finger and thumb, he is moving the lens of the camera very slowly or the screen very slowly so that he can pick up the best shot image position. So move the screen backward and forward slowly. It should not be or. Let me write it forward and backward. backward and forward slowly. Only one mark. Now, the shapes of the illuminated object and the image seen on the screen as shown in full size in figure 3.2 and 3.4. Measure HO and H1 and put them here. Okay. Now, when I'm placing the ruler there, so I'm getting HO, it is almost 2 centimeters, and H1 is larger, that is 3.2 centimeters. Calculate W using your measurements from D1. W is equal to HO over HI, 2 over 3.2. We are getting 2 divided by 3.2, 0.625. So 0.63, and there will be no unit. The reason for that, centimeter cancel with centimeter. So it is a ratio between the same quantities. Next, so table is given to us. The student repeats this procedure for U is equal to 20, 30, 40, 50, and 60 centimeters. His results are shown in table 3.1. U values are given, H1 are given, W are given. To plot a graph of U in centimeters on y-axis against W on x-axis. First of all, U in centimeter and W on x-axis. The first mark you have scored in this way. So first of all, what we are going to do, it is better for you, so you can make a line. I mean, you can label these axes. Y-axis for you, and similarly, you can make it for x-axis. Okay. We have to place these values. W values are from 0.4 to 2.9. So, and you don't need to start from 0. It's okay. We can start even from 0 here. Is 0, 0.5, 1.0, 1.5, 2.0, 2.5, and then 3.0. See, up to 2.9 you need. So more than half of the grid is covered. So when you labeled U in centimeters and W, scored first mark. Second mark you will be given when you will be placing the data numerical values on X and Y axis such that they are covering more than half of the grid on x-axis as well as on y-axis. So values of U are from 20 to 60. So let's start it from 10. Then this one is 20. This is 30, 40, 50, and this one is what? 60. Or we can do, because it is starting from 20. Okay. So let's even start from 20. Doesn't matter. So 20, 30, 40, 50, and this is 60. And now second mark is scored because our data is scattered on more than half of the grid on y-axis as well as on x-axis. Okay. Now see, when 20, so W is 0.4. Now here, one small square is equal to 0.4. 0.5 minus 0 divided by 10. So 0.05. It means two small squares equal to zero point 0.1. So at 20.4. So it means this is the point. First one. Then at 30, it is 1. 30, this is 1. At 40, 1.6. 40, this is 1.5 and two boxes here. That is 1.6. Then at 50, 2.4. 50, this is 2. This is 2.5. So here it is 2.4. And at 60, 2.9. So 2.9, just two boxes before 3. So now this is the third mark. And whenever you are plotting these points, you can use crosses, you can use plus signs or dot, but dot in a circle. Dot in a circle. Now, the final mark, we will draw the line here. And then mention draw the line of best fit. Okay, so we are going to draw the line of, try to draw the line of best fit. This is the line of best fit. 2 points are up, one is down, almost well judged line. Okay, so line of best fit. So this you score the fourth mark. Now, determine the gradient of the line. Show clearly on the graph how you obtain the necessary information. And whenever we are finding the gradient, we are showing a triangle and it is maximum, it is the maximum possible base. So see, I will be using this triangle shown like this. Then from here, like this. So I will take this value as x1, this is as x2. Of course, this is y1 and this will be y2. X1 is 0.4, x2 is 2.9. So we are writing these values. So gradient is equal to y2 minus y1 over x2 minus x1. y2 is 60, y1 is 20 over x2 2.9, x1 0.4. So this is 40 over 2.5. 40 over 2.5. 40 divided by 2.5. So answer is 16. So gradient is equal to 16. No unit is needed, but if you want to write, write over run. Run has no unit. Write has unit of centimeters. If you want to write, you can write. Otherwise, there is no part for writing the unit in gradient. The focal length f of the lens is numerically equal to the gradient. So record a value of f for this experiment. So gradient is equal to focal length, so 16.0 centimeters. Okay. Now, a student decides to continue the experiment using larger values of u. Explain why this procedure produces less accurate values for w. Larger values of u mean greater distance between the position of the object and the lens. And we have understood already this topic in paper 4 in the theory part, that as the distance of the object from the lens increases, the value of the size of the image decreases. So it means HO will be larger and H1 will become very small. As a result, it will be very difficult to measure the values of W. I'm going to write the values of H1 are becoming too small. Even sometimes we are too small to measure. In this way, question number 3 is done. Next is question 4. Of course, that is a flat. And I think there can be never easier question than this. A student investigates the relationship between the diameter of a wire and electrical resistance of the wire. Now here, key term is diameter of the wire and electrical resistance of the wire. So plan an experiment which enables her to investigate how the diameter of the wire affects the resistance of the wire. Here, friends, diameter of the wire is independent variable. Independent variable or quantity is a quantity which is changed by the teacher, by the experimenter. And resistance of the wire is the dependent quantity in this case. Dependent variable or quantity in this case, as the diameter of the wire will be changed by the student while performing this experiment, the resistance of the wire will be automatically changed. And this is very important to identify which one is independent and which one is dependent, because we are changing, we are repeating the experiment by changing the value of the independent variable. Also, the first column heading in the table, if they are asking, it is also the independent variable. So resistance is calculated by this formula, where V is the potential difference across the wire and I is the current in the wire. So very important. Potential difference is always across the wire or the component, and current is always through the wire or in the component. The operators available include wires of different known diameters. So you don't need to use the diameter in your workings or explanations. It is already known diameter wire. In your plan, list any additional operators needed. Complete the figure to show a circuit suitable for measuring the resistance of the wire. Then explain briefly how to do the experiment, including the measurements to take so that the resistance can be determined. State the key variables to keep constant, like the length of the wire will be the same, material of the wire will be the same. Then table with column headings and explain how to use the readings to reach a conclusion. So a very simple experiment. Let's start one by one. First of all, see, we need to measure the resistance. We are having the wire of known diameter, but nowhere it is mentioned about the voltmeter and ammeter. So the student needs voltmeter and ammeter. Already it is mentioned for what purpose they are used in the explanation of the experiment. An ammeter to find resistance of the wire. Resistance of the wire. Many wires here, of course. Next is complete the figure to show the circuit suitable for measuring the resistance of the wire. My dear friends, we need an ammeter to be connected. We need voltmeter. Here I can connect ammeter. Ammeter is always in series. Here it can be just connected with a lead, and voltmeter will be connected over here. because voltmeter is always connected across the component. Ammeter always in series in the circuit. Now, explain briefly, explain briefly how to do the experiment, including uh, these values. Now, we will start with that connect the circuit as shown above. Otherwise, there is no need. You can say connect one of the given wires, connect one of the given wires in the circuit. Note down or record its diameter because it is known diameter. Turn on the switch or you can say turn on the current. Switch is not mentioned in the circuit by the way. So you can say turn on the current. Measure current in the wire and potential difference across the wire. Now find resistance of the wire by R is equal to V over I. Then, my dear friends, repeat the same procedure or repeat the experiment by using wires of different diameters. As I told you in the beginning, this independent variable will be there for at least 1 mark to write, repeat the experiment by using wires of different diameters like this, in this, like here in experiment, because diameter is independent variable. Okay. Then next is, this is done, this is done, this is done. Now state the key variable to keep constant. So key variables to keep constant are length of the wires and type of metal must be kept constant for a fair test. For the type of the metal, it affects the resistance. And also the length of the wire, it affects the resistance. So these must be kept constant to make a fair test, a fair comparison. Then draw a table or table with column headings to show clearly how to display the readings. You are not required to enter any readings in the table. Now, as I told you for this table, definitely we are writing first of all the independent variable, which is the diameter. Diameter in centimeters. Then voltage in volts. Capital V for voltage, capital V for its unit. Both are denoted by the current in ampere. Resistance in performance. See, independent variable, the first column heading, and the dependent variable, which is the resistance of the wire, the last column heading. Now, of course, they will ask us to reach a conclusion. So we can say that plot a graph of resistance on y-axis, again diameter on x-axis to reach a conclusion. I'm writing the short words in short words. Even you can stretch it, draw or plot a graph of R on y-axis against diameter on x-axis, then study the graph or compare the results to reach a conclusion. But this is making sense and it is enough. Here also one thing more, dear friends. One more thing, my dear friends. Here we are having the numerical value of diameter. We are also having the numerical value of resistance. So we will plot a simple graph. Independent variable, which is in this case diameter on x-axis, dependent variable, which is resistance in this case on y-axis. Sometimes we have to draw a bar chart to reach a conclusion. What is that scenario? If this question was how the type of metal affects the resistance of a wire, then type of metal mean names of the metal like copper, aluminium, iron, silver, so on. We don't have their numerical value, but we will be having the numerical values for resistance. So in that case, when out of the two variables, one variable we have numerical value, for the other we have only the name, then we are plotting a bar chart to reach a conclusion. Remember it. Now, one more point I can add, and that is take at least 5 sets of data so that you can draw a very good graph, sensible graph. Take at least 5 sets of data, meaning what 5 values of R you will be having when you have connected 5 different diameter wires into the circuit. I'm sure this will be okay with you all. Stay blessed. And if you think that it is helping you to understand this paper 6 exam, so then do share it with your friends, family, and the world. And don't forget to follow the channel. Take care. Bye.